practice also, because this transaction theory and other related aspect of transaction theory is having some kind of uh, need some kind of practice basically. So we have organized or we have prepared some set of practice based questions or practice based assignments for this topic. So we will be sharing all those contents with you. So now I hope the screen is visible to you. So basically what we have done, we have partially covered all these basic concepts of transaction theory in the previous 4 lectures properly. So basically what this transaction theory is having the importance on concurrency control. So like in the previous lecture we have correctly pointed out that in transaction theory, to control the concurrent access of the transactions in a database system, we system is having two important components. The very first component is referred as a concurrency control protocol, and the second basically concurrency protocol or concurrency control subsystem. And second system we are having called recovery control, right? So recovery control system is for different purpose. It is for the purpose of recovering or rollbacking the transactions which get interrupted or and basically which get up some external external interference or external failures, right? So basically what we have observed that these two systems are basically responsible for maintaining each and every aspect of concurrency or concurrency of transactions, right? So now the focus of our discussion is to understand that what is the role of concurrency control. So concurrency control is primarily responsible for maintaining the concurrency, right? So maintaining concurrency means you need to have some kind of arrangement, some algorithm, or some you can say some set of protocol that how this is how we will be how this is how we will be entertaining or we will be managing the different transactions in the system, right? So we need to have a strategy. So concurrency control system or basically you can say the algorithm or procedure maintains some kind of protocols based on which it is maintaining the different maintaining the different transactions in the system, right? Because it is very usual that in a database system you might get hundreds of or maybe lakhs of transaction on a data item, single data value. Then you have to have a strategy based on which you can decide that which transaction will be going to manipulate or access the data value. So you cannot have a ad hoc approach. You should have a systematic strategy or a proper approach, proper set of rules based on which you will be deciding, system will be deciding which particular transaction will be getting the access to change the data value, right? So that's why we are saying, okay, concurrency control basically it is nothing but it is a set of protocol. It needs a set of protocol, and eventually these set of protocols will be implemented into a concurrency control module or concurrency control algorithm, right? So like in a common sense also, whenever we want to design an algorithm to maintain some procedure, to maintain some some function, you need to have some kind of rules. So similarly, to design a concurrency control protocol, we need to have some set of rules, right? So set of rules are like you will have basically okay. So basically we need to have, or we have actually 3 different protocols, or you can say 3 different solutions, right? So basically what we have done, we have actually not we have the different solutions has been proposed. Out of these different solutions, there are 3 major or main directions we have, and if you see that out of these many solutions, these 3 strategies are the more potent, or you can say the capable solutions are there, right? So the very first strategy or solution you can have to maintain or to manage the concurrent transactions or concurrency in the system is called phase locking protocol, locking mechanism, right? So that is something which we think of as a common sense or common solution, that whenever more than one transaction tries to access the data value, data item, we can have some kind of locking mechanism, right? That suppose transaction T1 already basically accessing the data value, no other transaction other than T1 should access the data value T1, data value X. So we can have a simple mechanism called locking. So whenever we approach or when adopt a locking protocol or locking mechanism, we have two steps, two phases. So whenever we adapt locking approach, locking strategy for concurrency control, we have this solution called two-phase locking. So two-phase means the very first phase of locking protocol basically emphasize on the locking of the data value. So whenever a transaction goes to access the data value X, he will simply issue a lock variable. So it will simply assign a value to the variable and say to indicate that no other transaction can access that value. Other transactions which are like after T1, whatever transaction is getting, like T2, T3, T4, whenever there is a access request for the data item X, they realize that okay, it is already engaged, that data value is already accessed by some other. So it is important to have first phase as a locking, second phase unlocking. So after using or accessing the data value X for their operation, it is important to unlock the variable so that other transaction, other waiting transaction can access, right? So this is the very first common sense based strategy. Second strategy is based on time stamping. Like, so the time stamping is something which we have a perception like each and every operation is having some time value. So this second strategy for concurrency control is based on the timestamp value. So value which is basically coming from the real time value, real, the time value, this time value, the time actually the real time which is occurring in the systems which are occurring in the real world also. So we will be using this time of occurrence of a transaction to maintain this kind of serializability in the system. And so in the protocols which are based on timestamps, they will be using the timestamp value for of each transaction to maintain this concurrency control. Similarly, on the last solution we have as a basically is the hybrid or maybe the extended version of these two approaches, locking and time stamping. So in case of third solution, which is the last solution, we have got this strategy called multi-version. So multi-version strategy says whenever we have concurrent access from the different transaction, you can create the multiple copies of the same data, and you can allot these different versions of the same data value to different transactions and have some kind of synchronization mechanism and achieve this concurrent access, right? But in the case of multi-version algorithms, we do not have any specific new strategy. There are two broad protocols or two broad strategies has been designed. The first strategy is basically coming from the approach of locking, and second approach is coming from the timestamp approach, right? So basically multi-version approach is having this tendency of creating multiple versions of the same data item. That is one part. But as far as functions or solutions concerned, in multi-version approach we will have these modified versions of locking and timestamping protocol, right? So with this, let's go to understand that how two-facing locking protocol will work, right? So in case of locking protocols, actually we have this very unique variable called a lock variable, right? Because in the database we will have multiple database items, and these different items will be accessed by different different transactions. So in the locking protocol solution or strategy, we will be creating, or system will be creating these lock variables. So lock variables are nothing. It is as same as the existing or previous variables which we are assuming in the programming language or data structure. So we used to create these lock variables. So for each data item, we'll generate or create lock variables, and these lock variables are available or maintained by the concurrency protocol system in our data structure, right? So like in the database, suppose we have 100 of different data items. So concurrency control mechanism will maintain these 100 different lock variables, each for each variable, right? Something like that. So so these lock variables, or maybe you can say the status of lock variable, the values of lock, because these are the variables. So naturally lock variable will have a value at any point of time. So this value of lock variable on a data item will indicate that what are the operations we can perform on that data item, right? So naturally, whenever we have a variable, we have some operation to we need some function, we need some operations so that we can update the status of lock variable. Like if you want to indicate that that particular data item has been engaged by some user, then you can simply modify the lock variable value of that data item X to some status. And if you want to make it free, or maybe you can indicate that this transaction has been freed now, it is available for usage by other transaction, you can simply update the status of lock variable of that particular data item, something like that. So in concurrency control, which we have solutions like locking, timestamp, and multi-version. Along with the strategy like lock variable, you need some operations also, right? So these are the two important aspects of any concurrency control mechanism. So let's open up a little about the locking variable. So in locking mechanism, actually we have first solution, which is called binary locking mechanism. So within this locking strategy, the first solution which were proposed in year 1988 was like binary locking. So in the binary locking mechanism, if you adopt the binary locking for your system, there will be only two possible state of your locking mechanism. So suppose there is a data item X and you have defined a lock variable on data item X. So there is only two possible state of that variable. So first state indicates that a data item is available, which is lock of X equals to 0, lock of item X equals to 0, which is means it is unlocked, it is available for usage. Second status value could be lock of item X is 1. It means it is already being used by some transaction for the operation, right? So that is the typical state of locker variable. But we need two operations, we need two functions to update the lock item X value, lock item X status, and that is called lock item and unlock item. So these are the two operations which will be required to basically update the status of the lock variable of any data item, right? So if you see, these are the very generic functions which are defined. So whenever in a database system or transaction processing system, there are various data values which are accessed by different data transactions. You need to maintain the list of, you need to maintain the list of transaction, you need to maintain the list of possible values of lock of any variable at any point of time, right? So whenever we are raising a transaction, whenever a user is raising a transaction in the system, it is very important to see the log of X value, and it is very important to raise these two functions, lock item and lock item, something like that, right? So if you read the function definition for lock item X, it means lock item X indicates a function call by some transaction who is trying to access data item X. So the very first step is is that transaction will verify what is the log of X stands for right now. So if log of X is 0, if current status when transaction tries to access data item X, and it realized that, okay, I'm going to use the value X, the very first thing I need to see the what status of log of X. So whenever a transaction initialized, the very first thing he will raise this log item X function, and in this function the very first instruction is to see the current status of the log item X, right? So what is the status of lock variable of that data item? That is the first thing you need to see. And if it is 0, it means that data value is available, and you can immediately do the lock X equals to 1. You need to immediately update the status of lock variable of data item, and then you can use it as per your requirement, as per your operation. Second, if lock variable is not available, if log of X indicates 1, it means that data value is not available for use. Then you have to wait. Then that transaction should wait in a queue, right? So there is a component called log manager, and it will simply maintain the queue, right, until the log of X becomes zero. That is the time when, till that time, you have to wait as a transaction, right? So these are the two possible steps. If lock is 0, you can use it by simply setting it 1, and if it is 1, you have to wait for the time that lock of X becomes 0, right? So that is two possibility of the locking item function. Next, after using, so if you got the access of data item X, then you can use it for your purpose for operation, and after completing your transaction operation, you need to set it as a lock X 0. So for that, you need to call this function called equals to 0. So whenever we have done with our transaction, lock of x becomes 0. So that is something is a procedure kind of thing, right? So the next thing which I wanted to highlight you that in case of binary locking, it is very important to see what are the different instructions or rules are defined. So these are the different rules which are defined, basically, or basically you can say generalized to design a binary locking protocol. So this whatever discussion we have in last 10 minutes, these are reflected in the terms of rules broadly, right? So the one typical problems which binary logging protocols used to face is the problem of starvation, is the problem of deadlock. So what are these terms are actually the starvation is a typical situation, like suppose you have adopted this binary logging protocol. It is a very usual scenario, it is a very common sense scenario that a transaction who have logged data item X might have this access for a longer time. It can engage the data item X for a longer time. So till that time, the other wait transaction will be on the waiting queue, and some might be having some timeout also issue. So basically, because this binary locking protocol is too much restrictive, it is too, I mean, it is too complex to be modified some other transaction. So it creates in some situation or some scenario, it creates this problem of starvation. Other transaction might get the signal that they will not get a chance to access data item X, so they will get timed out, or they will get terminated by the user forcefully. So one typical problem which we face in the binary locking is the starvation, is the deadlock. And other observation which has been received and observed, it's that binary locking is not considering the nature of transaction, right? So basically what we have done, uh, we have created a new solution, not new solution or new extension uh, for the binary locking protocol, and we have come up with the new locking mechanism which is called shared exclusive locking. So shared exclusive locking has this additional concept called we can have exclusive locking mechanism for read related access, and we have different locking protocols for write lock, right? So in the binary locking mechanism, we have only two possible functions, two possible steps. One is lock item, second is unlock item. But in case of shared exclusive, we have created for locking procedure, we have created two different functions. First is called read lock, second is called write lock, right? And there is unlock naturally, which will be required. So after this, now you can realize that for lock variable, we have three states possible: read locked, write locked, and unlocked. You can see here, right? So at any point of time, if you see the status of lock variable on any data item, you could found these three states: read locked, write locked, and unlocked. Similarly, if we have these status, you need to have these three equivalent functions. So along with it, let's see what is the possible the definition of now read log function and write log function. One thing you need to understand here: whenever a transaction tries to read a data value, whenever a transaction is try to read a value, it will simply access the data item. Because so there is the problem is with only write operation. If any data value and its log variable is set as a write logged, or it will be used for write operation, that is the only case when other transactions should wait, right? That is the one status. In other cases, like if transaction is trying to read is simply, and some other transaction is already engaged with the data value X for read operation, then that is not a case of conflict. So with this impression, the system immediately allowed to access the data value of ONX. So based on that acceptance, you can simply have this provision, like you can count the number of reads on a data item, right? And after that, after using these transactions for read and for write, you can issue unlock variable also. So it is quite similar to the binary locking protocol, basically, because it is extension of this protocol, which is called binary locking. But addition is only on this part. Like now we have these two possibilities of locking function. One is for read and another is for write lock, right? So this partially solves some kind of problems. We can have now more, I mean, more relaxed locking and unlocking procedure. So with this, we can have, okay, we have advanced locking management protocols, but it's still, I mean, it has been a wide observation that if you adopt any locking mechanism, you will face this problem of deadlock. You will face the problem of starvation. So that's why they have come up with the idea of solution called time stamping, right? So time stamping is a second strategy, or another strategy. So timestamp is typically it is a, you know, is a identifier tree. Whenever I say what is timestamp, so timestamp is nothing but it is a unique identifier. It is a unique variable which is assigned to each transaction. So it is because it is an alternative approach to the locking protocol. In case of locking, we have used this lock variable concept for each transaction, for each, not transaction, for each data value. But in case of time stamping, we have this concept called timestamp variable, and each transaction will be assigned a unique, you can say unique identifier, unique value, which is called timestamp. So timestamp value indicates a time value, actually temporal value, right? Which indicates broadly the time of time of the transaction began, you can say. So any transaction start time, broadly you can say. So this time of this transition time of each transaction will be maintained as a timestamp, and it is broadly used to maintain the concurrency, to achieve the concurrency in the system, right? So this adoption of timestamp value ensures one thing, that in the system there will be no possibility of deadlock, just because we have adopted timestamps. So one thing is observed clearly, that there will be no possibility of deadlock, just because it is capturing, or it is using the transaction start time, and it is prioritizing the transactions which are having just the last latest entry into the system, right? So that is one part. So instead of other variables here in time stamping approach, we are using the timestamp value, which is the start time of transaction. And based on that, system is, because within each and every transaction we will have these two operations, read and write. So you need to manage or maintain the read and write operation timestamp also. So we have now three timestamp value. First timestamp value is the transaction start time, which is the TS of T. Second is read operation timestamp, which is be read underscore times TS of T. So which indicates that, so suppose transaction T1 is having a read operation at certain timestamp value. So you need to maintain three timestamp value for any transaction. And based on these three values, you can organize, or we can have a strategy to manage the concurrent access of transactions, right? So that's why it is said that, okay, whenever you want to use timestamp approach for concurrency control, you need a algorithm. Naturally, you need a strategy for that, and for that you need to maintain these three timestamp value along with the actual timestamps of the transaction. So based on the read and write timestamp value on the data item X, so you need to have some comparison strategy. You need to have some serializability strategy, that, okay, I have captured the timestamp value of the transactions. Now I have to maintain the timestamp value or strategy of each read and write operation. And based on these timestamp value, I will be allowing some transaction, some operation to be happened or to be conducted, and other transactions, other operations might be waiting for, or might, I mean, about it also. So because in timestamp is basically works in the way that any transaction which is creating a problem, any transaction which is of the old timestamp value, will be eliminated or aborted from the system, right? So you can go through these simple instructions of time stamping ordering algorithm, and based on this, there is a first approach which is proposed, and it is called as basic timestamp ordering algorithm. So you can clearly see here we have basic two instructions involved. First instruction is for whenever we have whenever we have I mean, request from a transaction on right item X. So we need to see, we need to compare what is the current read timestamp on data value X, and if it is higher than the timestamp of t, so you need to perform something. And if right timestamp of x is higher than timestamp of t, timestamp of t means starting time of time, starting time of transaction, in that case you have to perform rollback of something. So you can see here for each, even for these two possible cases, based on the timestamp of transaction and based on the timestamp of read and write operation, you need to perform these instruction, these steps, right? So this is a typical or the simplistic model of timestamp ordering algorithms. So you can go through these instructions. These are the very generic instructions which are mentioned. These are the very common sense based algorithms or set of rules which have been designed. There are extension of these basic algorithms. So very first extension of this algorithm is called the strict TO algorithm, strict time stamping based ordering algorithm. That is for restricting the transaction. It is for prioritizing the right operation. So whenever we have this tendency of getting many transactions which are having right operation involved, so in the case of strict time stamping ordering algorithm, it is clearly pointed out that all the operations which are having right operation should be given a highest priority, should be given highest importance, and all others should be all other transaction has to be terminated, all that other transaction has to be aborted, right? So that's why it is called more strict or more rigid of it, and it is required in some transaction system that you need to prioritize, you need to give the importance, maximum importance, highest importance to the transactions which are having this kind of nature, right? So with this, I'm closing the discussion of this class, and these notes will be pushed to you on the platforms which we have created. And right now, if you have any doubt on this thing, that how to cover, how to prepare for these things, you can let me know.